So here the question is asking, can Symbol vector machine classify XOR training data set given this kernel? So we first write down the training set. So the training set for XOR is x1, x2, and say y. 0, 0 is 0, 1, 1 is also 0, 1, 0 is 1, and 0, 1 is 1. So then the next thing we do is we use this kernel to construct the new features, which are the original features are x1 and x2. So we know that it cannot be separated. So it's because these two are 0 and these two are 1. So there's no vector no line that you can draw to separate these two classes. So now we want to make three different features, phi1, phi2, and phi3. So the first one is just x1 squared. So here is 0 squared, which is 0, and here is square root 0 times 0, which is 0 again, and the last one is 0 for the same reason. So let's erase all of them and put in 0, 0, 0. So let's do the other ones quickly. This one is 1, this one is square root 2, and this one is 1. So basically substituting 1 and 1 in here, 1 times 1 is 1, square root 2 times 1 times 1 is square root 2, and this again is 1 times 1. So the other one is 1, 0, 0, and 0, 0, 1. So now you get these 3 points. You want to draw them in a 3-dimensional space to see if there's a plane that can separate these. So let's try to draw it. It's very difficult to draw it. It's easier, I guess, to visualize it. So this is our first point. Let's call it x1, x2, x3, x4. So technically these should be xi1, xi2, and so on. But in any case, this is our first point. And this is labeled 0 because y here is 0, and the other one is 1 square root 1. So this is phi1, phi2, and phi3. This is 1. Square root 2 is a little bit larger than 1, and phi3 is 1. So it should be somewhere here is labeled 0. That's x1. That's x2. And let's find the other two. So 1, 0, 0 is, this is 1, the other two are 0. 0, 0, 1 is this one. So these numbers are 1s. And these are also labeled as 1. And that's x3, that's x4. So let's see if there's a plane. There should be a plane like this. So you can imagine a plane going out of the screen and then actually cuts these axes like this that can separate these 4 points. So if there exists one, then there exists one with the minimum margin, and it is difficult to visualize what the SVM actually looks like, but there exists one. So this basically shows that there exist planes that are in between these two labels, these two classes. So there must exist one SVM that actually maximizes the margin.